Okay, let's go to the 40 video of our series, right? Into this case, talk about the use cases area of the topic learn about cloud. Basically, the first video about this topic. Into this use case area, basically you have some guides to common use cases, right? It's very interesting because it's very useful to make easier to build some solutions. Here we have the ticket routing, customer support agent, content moderation, and legal summarization. Into this one, ticket routing, we'll be able to route customer support tickets at scale. Customer support agent basically build intelligent context-aware chatbots. Content moderation, we have techniques for using Cloud to perform content filtering. And legal summarization, basically summarize legal documents using Cloud to extract key information expedite search. Let's see the first one, ticket routing. Depending on the size of this example, we'll make a video for each one, but let's see how big is this specific use cases. Okay, define whether to use some key indicator that should use an LM like Cloud instead of traditional machine learning for ticket routing. So the point here is basically if you need to make the routing of a ticket, you can just make a simple analysis, or you can use LLM for that. Simple into this case depending on the machine learning approach that you're using. If it's just a simple script to verify specific terms, it could be named as simple, but if you are using machine learning for that, not necessarily simple. And if you are using code for integration, it could be very simple, but internally a lot of processes are being executed to make it possible. Okay, traditional machine learning processes require massive level data sets. Cloud's pre-trained model can effectively classify tickets with just a few dozen labeled examples, significantly reducing data preparation time and costs. What it means? In a brief, it's basically if the user sends a message for the system to a machine learning model, understand what what location you need to send the user to. You need to make a training with a lot of labeled data. You need to have a data set and worksheet, you can see in this way, with what is the expected message and what is the expected route and location. Basically that. We can see the labeling of specific user messages. And with a large data set, you'll be able to create a model that could understand how to make these routing processes. How much complex is that? It will depend a lot of the machine learning model that you use, and of sure you will have a lot of work to make the labeling of this data. With Cloud, Cloud was basically trained with a very large data set with much information available on the internet, probably other proprietary data sets from Anthropic. So it could be it would probably already have the information on how to make this type of routing if you describe well how to do that, right? So you don't need probably a labeled dataset, and all the processing will be done by code, so it'll be probably very faster. It's an interesting use case. Your classification category is likely to change, yes, because if you need to add a new category, your machine learning model will need to be changed to add this new feature. I believe that we can talk in this way, because you need to send a new dataset to train the machine learning model to add this new feature. With Cloud, you can just add to the prompt the information that you need to verify. Sure, you need to make tests to verify if it's everything working as expected, but in terms of expanded work, it's significantly less work. You need to handle complex and structured text input. Traditional machine learning model often struggle with unstructured data. Yes. Cloud advanced language understanding allows correct classification. Yes. Okay. Your classification rules are based on semantic understanding. Basically, depending on the architecture that you're using with the machine learning, it will not be so sophisticated to understand some type of examples. Interpretable reasoning for classification decisions. Okay, you want to handle edge cases effectively. You need multilingual. Oh, it's another very interesting. The other points are interesting. I did not get some details here, but about the multilingual support, it's also very interesting because for machine learning approaches or manual approaches, you need to understand what the users were talking about and making analysis of related to that based into words that they use it. But if the user is not into your default language, probably your model will not understand it. With Claude, it will be able to automatically have multilingual support related to the scale where the scale of the dataset that the cloud user to be trained in. Build and deploy your LMS support workflow. Let's see. What criteria are used to determine what SLA service offering is applied? Is ticket routing used to determine which tier of support or product specialist the ticket goes to? Are there any automated rules or workflow already in place? Okay, we have here details about the current support approach, understand how it's currently be done, the support to be able to automate it. Define user intent categories. Depending into the user message, you need to understand what is the user intent, right? The user intent could be defined in some categories. Into the documentation, we have some examples of that. If a technical issue, account management, product information, we have some details here, feedback, and a lot of other categories that will depend of your user case of your work or your business. Okay. In addition to intent, ticket routing and prioritization may also be influenced by other factors such as urgency, customer type, SLAs, or language. So it could be interesting to send the routing not only the category, but cloud it's capable to receive user message and return this type of category very easily. But it's also interesting to return the urgency, customer type, if you have some contract dependencies, and the language in your brief. With that, you can make a better routing. Establish success criteria. Just getting the return from cloud, it's very easy, you know. If I with the current APIs, it's very easy to make that. You can just make a prompt to explain what you want to return in JSON format, and it will be returned, right? But how can I measure if this simple integration, simple implementation, it's a success? So I need to have it clear. So for that, it's interesting to understand how to measure classification consistency, if the message that I'm sending are being well classified, if it having a very good velocity of adaptation, how it's being handled multilingual cases and edge cases, if something weird it's requested, how it's being handled, if you having some type of bias, if the prompt is efficient, and if you are being able to have good explainability about the results. Let's see how it's okay. Basically, here for classification consistency, basically it's interesting to have some standard inputs, right? to verify if the model will be able to reach to these standard inputs. I'm in a consistency rate of 95% or higher. Speed of adaptation measures how quickly code can adapt to new categories or changing ticket patterns. Test this by introducing new ticket types and measure the time it takes for the model to achieve it for satisfactory accuracy. Aim for adaptation within 50 100 sample tickets. Multilingual, basically it's using the system here to get this type of information. Right, multilingual, we have some examples with other languages. Edge cases basically and having test set with edge cases. Bias mitigation, it's related to analyze different customer demographics. I believe that analyzing if with different approaches of conversation, how it's being routed, if you have if there is some type of misuse of the system related to how the model is interpreting the message overall. Efficiency of the prompt, if it's getting good results, and if the human could explain the results. Okay. We have other issues criteria. Interesting. The choice of model. Let's go to the next point. Choose the right cloud model. The choice of model depends on the trade-offs between cost accuracy and response time. Many customers have found Cloud 3 Haiku ideal model for ticket routing is the fastest and most cost-effective model in the Cloud 3 family, while still delivering excellent results. If classification problem requires deep subject matter expertise or a large volume of intent categories, you may opt for larger sonnet model. Build a strong prompt. Here we have a prompt to use for that. It's been used as XML to get information from requests because this XML here into Cloud it's very used and it has a very good results. Right, using XML to interact with Cloud it's very effective normally. Because of that, it's well common to be mentioned into documentation. You can see here we have HTML with the request and an XML with the output to the intents and the brief. Some examples to be used by Cloud to return the response. And great. Let's break down. Okay, to get the ticket contents with some examples. Deploy prompt. Redeployment structure start by define the method signature for record to upload. It will use the Anthropic API here, which is this example to make the support request. Right, classify support request. Great, it's basically just return the intent and make a similarity to get the XML return. The reasoning basically it's to get some explainability. But our main objective is the intent to make the routing, right, into a chatbot application, for example. The rest of this guys may have already developed test case, great, with the evaluation function. Our example evaluation for this guide measures Cloud's performance along 3 key metrics: accuracy, cost per classification. It should be 3 now. Okay. You may need to access cloud and other access depending. Okay. Right. It will make the execution of the request, get the reasoning and intent, and how it's being measured, the information, the accuracy and cost per classification. Get user statistics for the API call. Okay, this is the cost basically, and here it's measured the accuracy. Okay. Okay, this is just a request, and to make the evaluation, it is a request that already have the information of the actual intent. It will be run through and testing dataset and be able to get information. In this way, we'll be able to get information for accuracy, since it's a random test where theoretically you'll have the information of how the route has been made, and we'll have the information for cost, to get and to be able to calculate the cost per classification. Okay. As the number of classes grow, the number of examples required also expands, potentially make the prompt unwieldy. As an alternative, you can consider implementing a hierarchical classification system using a mixture of classifiers. Oh, interesting. This is very interesting, because other point that I don't mention in complex scenarios, it may be helpful to consider additional strategies to improve performance beyond standard prompt engineering techniques and guardrail implementations. Okay, well, here are the commissioners. Organize your intents in a taxonomic tree structure. Create a series of classifiers at every level of the tree, enable a cascading route approach. For example, you might have a top-level classifier that broadly categorizes tickets into technical issues, billing questions, and general inquiries. Each of these categories can then have a town subclassifier to further refine the classification. The use were made, I guess. Basically, here we have the support ticket that to be sent to 3 different taxonomical classification, technical issues, billing questions, or general inquiries, and they do have different classifications. So we have here two calls for upload, I guess. First one to analyze the taxonomy classification, and the last one to get the intent based on that. Let's check if that provides greater nuances and accuracy. You can create different prompts for each parent path, exactly, allowing for more targeted and context-specific classification. This can lead to improved accuracy and more nuanced handling, and it will get more latency because we'll be doing more requests. Yes, we recommend implementing this approach for first test model Haiku. So for points where latency could be critical, Haiku could be a very great approach. Use vector database and similarity search retrieval to handle highly variable tickets. This part provides examples being the most effective to improve performance. If support requests are highly variable, so just with taxonomy classification it will not be able to handle it, it can be hard to include enough examples in a single prompt. In this scenario, you could employ a vector database to do similarity searches from a dataset of examples and retrieve the most relevant examples for a given query. This approach, outlined in detail classification HACCP, has been shown to improve performance from 71% accuracy to 93% accuracy. One point is that this approach is only available, is only the most interesting if you have to handle highly variable tickets. If they are not highly variables, these accuracy improvements could not happen. It would depend a lot to your case. Account specifically for expected edge cases. Here are some scenarios called my misclassified tickets. Okay, customer make implicit requests. Customers often express needs indirectly. For example, I've been waiting for my package for over 2 weeks now. Maybe indirect request for order status. So it's not something so direct. Humans normally are not so direct than we expect to when planning in a chatbot scenario. Maybe into this case for the user it's very clear that it wants order status, but for the bot probably not. Solution: provide the code with some real customer examples of these kinds of requests along with what the underlying intent is. You can get even better results if you include a classification rationale for particularly nuanced ticket intents. So basically you need to have real interactions with your chatbot to put the human in the loop and understand how these edge cases could appear to find examples for that or add it to the vector database. Cloud prioritizes emotion over intent. When customer expresses dissatisfaction, Cloud may prioritize addressing the emotion over solving the underlying problem. Solution: provide Cloud with directions on when to prioritize customer sentiment or not. It could be something simple as ignore customer emotion, focus only on analyzing intent in the customer requests. Basically, if Cloud is not locating directly the intent, you can just use some prompt engineering to force it to be its behavior. Multiple issues cause issue presentation confusion. When customer present multiple issues in a single interaction, Cloud may have difficulty identifying the primary concern. Large language models are not so good to analyze multiple points at a time. We too, into this case, we aren't also so good into analyze multiple things at the same time. Clarify the presentation of intent so that Cloud, we need a space here. Cloud can better rank the stated intents and identify the primary concern. Let's if the user sends multiple issues, you need to clarify into the prompt what is the main intent that need to be analyzed first. New brief, it's basically that. Integrate Cloud into a grid support workflow. Okay, proper integration to the push-based support ticket system you're using. Example, Zendesk triggers your code by sending a webhook event to routing service, which then classifies the intent and routes it. This approach is more web scalable but needs you to expose a public endpoint. Yeah, it's very good if you are working to a system as a service approach or something that you need to be public. Pool based. You code pools from the latest tickets based on a given schedule and routes then at pool time. The approach is easy to implement, but making necessary calls to the support ticket system and proof frequency is too high. Basically, what has been technically how to integrate cloud into system. Basically, you can integrate with webhook based into the patch idea, or you can make periodic calls for your system based on your pull idea. The both approaches will work. The push one will be something more reactive. The Zendesk, for example, send a hook request. And into the pull based approach, it's something more proactive because your system will periodically make requests to the ticket systems to analyze how it's been working. Further to this approach, you need to wrap the scripting service. The choice of approach depends on what API support ticket system provides. Great, very great guide with a lot of relevant content and a very long video, at least based into the other videos. Okay, I mentioned that if this video becomes very long, I will not proceed with the other cases. These other 4 use cases that we have here will be analyzed into other video. Alright, and doubt you can be free to comment, and other point you can be free to comment. We talked about a lot of points here. If you want to have some specific ticket related for that, you can just send me into the comment or send me an email. Thank you for your time. Have a great day.